Assalamu alaikum. Dear students, welcome to the second lecture on foundations. Now we will discuss about design criteria and pressure distribution under footings. Coming first to the design criteria. There are three basic requirements for the design of the foundations. They are maximum pressure on the soil, does not exceed the safe bearing capacity of the soil. The foundation should be designed in such a manner that it transmits the applied load to the soil below without exceeding the safe bearing capacity of the soil. Second requirement is that the total settlement of structure is less than permissible value. Almost all soils get compressed under load and certain amount of settlement is bound to occur. But it's necessary to ensure that the total settlement of the structure is within permissible limits and is as nearly uniform as possible. Coming to the third requirement, stability against overturning and sliding. The foundation should be provided in such a manner that the structure does not get tilted under the load. For example, if we have two columns, column 1 and column 2, spaced at a distance x center to center, let the load on each column be equal to P. Now if we provide a rectangular combined footing under both these columns having length equal to L, this offset should be equal to this offset. Here the CG of the loads will lie exactly at the middle of the two columns, that is at a distance x by 2 from the center of column 1. Here the CG of the footing will be at a distance L by 2 from this edge of the footing. Here we can see that the CG of the loads is coinciding with the CG of the footing and the resulting soil pressure will be uniform here and here. It will be same. if the soil pressure here is equal to Q, the soil pressure here will also be equal to Q. Now consider second case. If again we have two columns, column 1 and column 2, spaced at a distance x center to center, let the load on column 1 be equal to P and the load on column 2 be equal to P plus delta P. Again, if we provide a rectangular combined footing here having length equal to L, here the CG of loads will lie more towards column second, but the CG of the footing will be at a distance L by 2 from this edge of the footing. Here we can see that the CG of the load is not coinciding with the CG of the footing. There is some eccentricity E. In such a case, there will be higher pressure on the edge of the footing which is nearer to the CG of the load, and there will be lower pressure on the edge of the footing which is away from the CG of the load. The higher pressure at this edge will cause greater settlement of the soil at this edge, and it can result in tilting of the foundation. This can be avoided by providing the footing area in such a manner that the CG of the load coincides with the CG of the footing. Now coming to the pressure distribution. Under footings, the theory of elastic analysis as well as active observations indicate that the pressure distribution under symmetrically loaded footing is not uniform. The actual stress distribution depends upon nature of soil, and rigidity of the footing. When the rigid footing is placed on loose cohesionless soil, the pressure is more at center due to the confinement of soil and is less at the edges because the soil grains at the edge of the footing have no lateral restraint and they displace laterally. The resulting pressure distribution is like this, that is, more at center and less towards edge. On the other hand, in case of a rigid footing resting on cohesive soil, the load transmitted by the footing causes very large pressure at the edge and lesser pressure at the center. And the resulting pressure distribution is like this, that is, more at the edge and less at the center. However, to simplify the analysis, the pressure distribution beneath a footing is assumed to be linear. The influence of this non-linearity on the magnitude of bending moment and shear force in RCC footings is relatively small. Hence, linear pressure distribution is considered to be acceptable. Thank you.